Hey, fellow mathers, before we get into this episode, we want to share with you how you can get access to free content, professional learning that will keep your students engaged and doing the math that matters. Get ready to go to this link, mathisfigureoutable.com/challenge.
That's right. Registration is open for the free Math is Figureoutable Challenge that's starting May 15th and runs to the 17th at 7 p.m. Central. We're going to have 3 nights jam packed with learning and routines that you can take straight to your classroom.
In these challenges, we have a great time. We do some math, talk about classroom experiences, give away super cool bonuses and prizes. You won't just walk away with routines that are naturally engaging and encourage your students to think mathematically. You'll also have a chance to win over 6K worth in prizes, including a few virtual PD sessions for your school. I'll be joined by my wonderful co-host Kim and special guest Jenna Labe.
You can register at mathisfigureoutable.com/challenge for a fantastic learning experience. That's mathisfigureoutable.com/challenge. Now on to the show. Hey, fellow mathematicians. Welcome to the podcast where math is figureoutable. I'm Kim.
And I'm Pam.
And you found a place where math is not about memorizing and mimicking, waiting to be told or shown what to do, but it's about making sense of problems, noticing patterns, and reasoning using mathematical relationships. We can mentor students to think and reason like mathematicians. Not only are algorithms not particularly helpful in teaching mathematics, but rotely repeating steps actually keep students from being the mathematicians they can be.
Bam! Nice. Good job, Kim. So it was funny when you said I'm Kim and then you laughed. I was like, oh, that's right, because I got to say I'm Pam because I was about to say and I'm Kim, and that would have been silly.
That would not be good.
We kind of have that written, obviously, people, and so she was reading it when you said I'm Kim. I'm like, that's not what it says. Oh, right, because
Hey, I have a question. When
Yeah.
I was saying it this time, did you do what I do when you're saying it because you've heard it so many times and like say it
in my
along in your head?
Yeah, pretty much. Yeah. All right, we thought we'd give that a try, everybody. Well done, Kim. That was kind of fun. Why not? All right. Hey, let's start today with a fun comment that I got on Facebook from Nikina, who said, "Hi, Pam. I wanted to let you know how your podcast is helping me. I don't remember exactly how I found you, but it was from other podcasts that I was listening to specifically for elementary info. I'm not a teacher, just a parent who wants to get my math brain fired up so I can engage my children with thought-provoking games when they are developmentally ready." Ow!
Love
That
that.
is amazing. So, Nikita, that is fantastic. And I'm so glad that somehow some other podcast was saying something about our podcast. That's wonderful. And I'll just maybe mention often, way too often, people will say, "Oh yeah, Pam, you're elementary." And I'm like, "Well, yeah, but I'm not only elementary." It's actually funny that people say I'm elementary because I started secondary. Anyway, but I'm super, super grateful for that Nikina found us and that she's able to use some stuff with her kids
Yeah.
because we like parents.
Yeah. Well, and it's funny that she said, I'm not a teacher, just a parent. I mean, parents are their kids' first teachers.
Absolutely.
Like
And
if,
probably
yeah.
best teachers, right?
Yeah. Oh, for sure.
Yeah. Yeah.
Well, speaking of parents, we want to welcome you, parents. This episode is for you. We know that you love your kid, but you may or may not love math, and we can work on that. So we have some
Bam.
tips and ideas for you that you can do in tiny, tiny bits of time that will make a huge difference for your students, no matter their age.
And no matter, like you said, if you love math, if you have a shaky relationship with math, either way, we've got some ideas that can really help you with your students do more and more math at home.
Yep.
I've learned a ton from Kim. Things I do with my kids, my grown kids right now, that she's doing with her teenagers. Lots of fun math that we can do all the time. So we have some tips that we'd like to start with. We're going to start with some general tips, and then we're going to do some mathy things. So, Kim,
Yep. Yep.
first general tip that I'm going to mention is let's recognize, to start off just off the bat, that adults might have some math baggage that our kids don't have and maybe don't ever need to have. Like I was about to say don't have yet. And I was like, oh, let's not say yet there.
Right.
let's say that maybe they don't have it. How is that helpful to recognize that?
So we as adults kind of set the tone, right? And so if we have concerns, well, I was going to say let's not share those right away, but in general, we might have some nervousness or some worry about math that we might suggest to our kids if we're focused on the baggage that we've had.
Or if we don't focus on the fun we're having now.
Right.
Yeah. So let's say that you did have some traumatic experiences in your past with math. Many of us did. Many people have horrific memories of time tests or of getting something wrong in front of their peers or being called to the board in front of people and when you don't know what you're doing. Rather than saying somehow rise above those, I wonder if we could actually just say, like, those are real, but
Yeah.
let's dive in now with our kids and do some things in the moment now. So like
Yeah.
actually math with your kids now, not rote memorize, not try to don't go back in that place where you're like, oh, I never did this well. I'm still not going to do it well. I'm going to look like a dork in front of my kid. Actually, just like we're going to try to give you some things to do in the here and now where that you can math together. And as your kid
Right.
goes, whoa, you didn't know that? You could say, isn't math cool?
Yep.
Instead of responding with, no, I didn't know that, you brat, or I should have known that, like in some
Yep.
sort of, you can just like, yeah, isn't it cool that we are all learning together, that math is so deep and interconnected that we can keep thinking and playing with relationships? Isn't it cool? That
Yeah.
could be a way to kind of respond to that. Yeah.
Yeah, because the big idea, right, is that our kids may not have that perspective and they don't have to. Right? We can
Yeah.
we can help them have a different path. And so to do that, we'd like to recommend that you avoid phrases like I can't do math or I was never good at math or your other parent and I struggled in math. And we want to embrace the idea that all people can math.
Absolutely. Yeah, I've been in parent-teacher conferences where parents will say in front of their kid, "We just don't do math in our family.
Mhm.
We're not math people. We don't do
Yep.
math. I've never
Yep.
been good at math. My significant other or the parent has never been good at math." And let's avoid those. We could just we you could say things like, "Math was hard for me as a kid, but it's really interesting now." That would
Mhm.
be okay.
Mhm.
Maybe even I tweak that with like, "Fake math was hard for me, but
Mhm.
real math is cool."
Mhm.
I can't tell you the number of people that I talk to, kids and adults and everybody in between, that when I say, "Oh yeah," they'll say, "I wasn't good at math." And I'll say, "You know what? I bet you weren't good at fake math. I bet you
Mhm.
actually could do real math." They just kind of light up. So there's this idea, it might be okay. I don't know, Kim. I guess maybe I should ask you. Do you think it's okay to tell a kid, "Yeah, I wasn't really good at fake math, but
Oh yeah.
real math is
Absolutely.
cool."
Yeah,
Yeah.
absolutely.
Who cares about being good at something fake? Oh,
Yeah.
yeah.
So, parents, we would invite you to come along the journey that we're kind of working on with teachers and other parents and ourselves to build our own numeracy. And you can engage in that in a lot of ways, but building your own numeracy alongside your students shows them that you're open to thinking and it frankly it can be a lot of fun together.
Absolutely. And when we say numeracy, we kind of use that as a global term to mean the way you think and reason about
Hmm.
numbers. And then beyond, you could think and reason about geometry and the way you think and reason about algebra and higher math. But this idea of let's build some together. Let's
Yeah.
build the way you think. So when Nikina said, "Hey, I'm super glad to get some of the thought-provoking games," I love that you can get some good thought. And we're going to do some things here, some thought-provoking games. When we say build your own numeracy, we're suggesting dive into the game yourself. So it's
Right.
not about how we're in the car, "Hey kid, go play this game." Or, like, "I'm the master and I'm going to tell you the things and you learn from this." That it really is, much more game like. I think what Nikina means is we're going to play together. Like, these are games that we're diving in and I'm going to be thinking, you're going to be thinking, we're going to share our thinking. And that's going to work better than, boy, do I have a task for you now. No, it's
Hmm.
like
Hmm.
game, like make it game like and thinking. And
Yeah.
Kim, if will you share with everybody? I think one of the coolest things I ever heard you say was the one day that I think you were in the car. I don't even know. You were going somewhere and one of your kids asked to play a specific game that you didn't even know you guys had been
Oh,
playing.
yeah. Yeah, when I had, my kids were a little bit younger and they were both in the back seat, one of them said, "Hey, mom," we were driving a while, and he said, "Can we play the Wonder Game?" And I was like, "What in good gravy is the Wonder Game? I have no idea." And I said, "What are you talking about?" And he said, "Where we ask a couple of questions and then we choose which one we want to think about." And it came from the fact that I would just talk out loud and I would say things like, oh, we're at exit 275. I wonder how many mile markers it is till we get to number 300. Or, oh, hey, the speed limit is whatever. And I would just wonder aloud about questions and they would chime in with me. And then we'd choose one to continue the conversation about.
We've been driving for 15 minutes, and it usually takes us blank to get to Dad's work, and that's where you're
Mhm.
heading, maybe.
Yeah.
I wonder how long it's going to take us to get there today. I wonder,
Yeah.
how much longer. Like you just started. In fact, I'm going to push you a little bit. Can you remember any other things that you might wonder while you're?
How far away things were off the side of the road, how long it would take us to get to those.
Mm.
Um, yeah.
Did you ever ask?
Um,
It's this time now. I wonder what time we
oh,
left
for
home.
sure. Yep.
Uh huh.
Yeah. Anything about our kind of our speed or the distance we had to go. Sometimes something like on the side of a truck would give us something to wonder about. It would have a price or it would have, you know, we would wonder about the phone numbers and the digits. We just were really open to talking about anything that sparked us. And it became a game, really.
Hmm. One of the reasons why I pushed you to kind of say a few more was the very first time I heard you talk about this. I was like, "What would you wonder about?" Because
Yeah.
I did not see. And there were two things happening. Part is I'd never like kind of thought about it at all, so it was a new idea to me. But also this was early when you and I had just met, and I didn't when it very first came up that you would ask your kids questions like this. I was like, in fact, I think we were talking about at the grocery store, like, Pam, when you walk in and you see the price and don't you say to yourself, I wonder how much that would, how many pounds I could get for blank, or, oh,
Yep.
if I look at the oranges in the case and it's like, I wonder how many oranges are in there. And you're like, how you wonder, or you look at as you're running down the road and you look at help me, the
House
address,
numbers.
the house number. And you say to yourself, is that prime?
Oh,
Is that a
yeah.
palindrome? Is that divisible by, and you said,
Yeah.
Pam, when you
Yeah.
think like things like that. And I was like, no, I don't ever think about things like that. So early in the game between you and me, early when we met, I had not built my own numeracy. And
Yeah.
so I didn't have relationships to play with. It
Right.
wasn't fun for me to play with the house number because I
Hmm.
didn't even know what questions to ask because I didn't own enough relationships to do anything. But as
Yeah.
soon as you started saying some of the questions and I started doing some of the routines and the games that we're about to talk about, then my brain had some relationships to hang on to begin
Right.
to ask more questions. But if
Right.
I can say one more thing about that, even on my journey to build my numeracy, to build my math, the more questions I would ask, the more I would get ideas from whomever I was talking to. So if it was my kids, if
Mhm.
it was whoever else that I'm wondering about, then they would be like, oh, well, I'm wondering this and wondering that and wondering. And then they would pop in things so it's not all on you, parents. It doesn't have to be
Right.
that you come up with all the magic. You can just start the conversation.
And kids are amazing wonderers. And just because you wonder, it doesn't mean that you have to know the answer or chase it down. Sometimes just raising the things that people wonder about is rich in itself.
Oh, that's a good point. Yeah.
Yeah.
Yes. Yes. Because in fact, I'm super glad you said that. Because when I very first heard you talk about it, I thought I had to chase them all down. And I was like,
Yeah.
I don't know how to chase that down, nor do I know if I want to chase
Yeah.
that
Yeah.
one down. Yeah. So that kind of freed
Yeah.
me up to just wonder and not have to worry about it. Okay. Kim, what are some things that parents can actively do, and teachers, but we're focusing on parents today, can actively do with their kids to build some of those relationships so that then we can play with them?
Yeah. So it might sound pretty simple and it is as a routine, but you can double numbers with your students. So you might say, okay, we're going to start with the number 5. What's double 5? And they say 10. And then you say, okay, what's double that? And they say 20. And then you say, what's double that? So getting kids to start thinking about doubling numbers, which then leads to work that they'll do with multiplication. So
Absolutely.
literally just doubling. And then you say, okay, so what's you did 5s or some number. And then you say, what's double 3? 3 and 3, 6, double 6. Then you can double some kind of maybe
Cranky.
stranger numbers. Yeah, funkier numbers. And you say, what's double 13 and a half? What's double 27? And kind of rich conversations about which numbers were easier to double. How did you double it?
Nice. And one place I'll take that. Let's say that you had doubled 75.
Mm-hmm.
Then you could say once double 75, pause, is 150. You could say, well, what's double 750?
Mm-hmm.
Is that 1500? Does that have anything to do with that 75 and 150, 750 and 1500? How about double 7.5?
Mm-hmm.
So you can kind of have some place value relationships back and forth with that doubling. So
Yep.
yeah, doubling. And why double? Mathematicians play with doubles. They
Yep.
recognize doubles and they use doubles in their work. And once I knew that, which I didn't know that for quite a while, but once I knew that, then I was like, oh, let's play with doubles. Let's do some more doubling. And then doubling can be kind of cool.
Yeah.
And then Kim, once we've doubled with students enough that they kind of have some feel for doubles, so you don't have to like double all the things to wait until you do this next thing, but double a bit so kids kind of start playing with doubles. Then you can begin to find halves. You can have with students. Have is a funny word in the English language, like half, like find a half, but you have V in there
Howls,
anyway.
howls.
Halve, that silly word. So then you can start with, I don't know, half 14.
Mm-hmm.
And if they've been doubling with integers, they might have some sort of half of 14 is 7, and then you might say, okay, well, what's half 16?
Mm-hmm.
And they might say, well, half of 16, okay, that's 8. We know those, Mom, those are easy. Well, then you might say, well, what's half 15? So if I've halved 14 to 7 and half 16 to 8, half 15, is there some
Yep.
relationship there? I'm almost doing a problem string as
Yep.
I'm having numbers. Now you don't have to you don't have to do that. But you could then even do, so if you've doubled 14, 16, 15, you could even have 14 and a half. What's in
Mm-hmm.
between 14 and 15? And I got a little crazy there, but half 30, half 35, half 72, half. Yeah, often the numbers 36 and 72 will come up, and people will say, how do you know those are connected? And I'm like, wow, I've just been doubling. I've been doubling 36 so often that it turns into 72. So then when I see 72, it's like half of that's 36. So those relationships start to ping for kids when they've played with doubles and played with halves. Do you have anything you want to throw in for halves?
Well, I want to say something about both doubling and having. You can absolutely do these routines as you're driving down the car or driving down the road, like we just mentioned, but it also can be something that you're doing at the dinner table. You don't have to write something down, but there might be times where just keeping track on paper of what students have said, but it might be helpful. But in all of those situations, asking them, how did you think about that?
Oh,
How did
yeah,
you
yeah, yeah.
know is super important. So, you're going back and forth saying numbers and they're giving you numbers back, but pausing every once in a while and saying, like, how did you do that one? What were you thinking about? What pieces did you use?
And sharing how you were thinking about it.
Yeah, for sure.
Yeah, absolutely. And yeah, cool. All right, let's do another one.
What about in general looking for relationships? Like the idea of 248 we mentioned with doubling. Tell us a little bit about thinking about nines.
Yeah, so we want kids thinking about doubling. So when they think about times 8, they're like, well, I could double to get up to that. But if I'm thinking
Uh-huh.
about nines, like Kim just said, is that related to tens? So in a couple of ways, could I think about if I'm going to add 9, could I add 10 and back up one?
Yeah.
9 is so close to 10. Is there some? And often people kind of have this kind of sense that, yeah, 9 is like this one less than thing. But they really
Mhm.
have never talked about it. So the more you can kind of talk about that thing that's kind of happening in your head with nines for addition, but you could also, if I'm supposed to subtract 9, could you subtract 10? And then well, you better give one back because you subtracted too much. Or if you're going to multiply by 9, could you multiply by 10 and say, well, if I need 9, grab a random number, 14s. Could I think about 10 14s? 10 14s is 140, but I only need 9 14s. Oh, better get rid of an extra 14. And now I got to think about 140 minus 14. Hey, I can think
Mhm.
about that minus 10 that we just talked about. So looking for relationships like double to get to 8, tens to get to 9. One other favorite relationship that we really like is to get to 5. Think about the relationship between 10 and 5.
Yeah.
So if I'm thinking about 5, how does that compare to 10? So for example, that 14 we just had, if I want to find 5 times 14, I can think about 10 14s. 10 14s is 140. So 5 14s is got to have to be half of that. Half 140. Bam. Hey, look how we're having. Hey, Kim,
Mhm.
having just showed up.
Mhm.
So if I think about half of 140, then I'm at 70. And indeed, is 5 times 14 70? And you can check that out if you want to. So some relationships that are super handy and can come in really, it can be very useful as students are thinking are doubles, 2, 4, 2, 4, 8, and how 9 is related to 10 and how 5 is related to 10.
Another really important relationship is the idea of 10 more or less than a given number, or 100 more or less, or 1,000 more or less. So for instance, if I said 64, what's 10 more? Students would say 74. And if I said, what's 10 less? They would say 54. This has huge implications for place value development that kids
Mm-hmm.
need. And once kids are able to tell you 10, 100,000 more or less, then you can move to 9 more or less than a particular number.
Yeah, in fact, Kim, this is one of my favorite things to do with a kid that I've just met.
Mm-hmm.
So somebody's like, "Hey, do math with the kid," and I'm like, "Okay, I'll just off the cuff, I'll just do some math," which is totally fun. But I'll look at the kid and I'll like, I don't know you. Let me see if I
Right.
can get a feel for you. So depending on the age, especially if they're like 8 or above, I'll say something like, "Hey, do you know like 46 plus 10?" And then depending on what happens, if the kid has some sense that 46 plus 10 is 56, then I might go, "Oh, that's cool. What's 46 plus 9?"
Mm-hmm.
And then I'll go back to, "Hey, what's 83 plus 10? What's 83 plus 9? What's 147 plus 10? What's 147 plus 9?" And then
Mm-hmm.
depending, if that goes really well, then I might say, "What's 147 plus 100? 147 plus 100? Okay, if that's 247, what's 147 plus 99?"
Mm-hmm.
So this idea of knowing what any number plus 10 is, any number plus 100, let's do any number plus 1,000. If it's going well at that point, I might go, okay, 792. Well, I might, it depends on the age of the kid. I'll do this one first. What's 792 plus 1,000? Usually that gets a big grin. They're like 792 plus 1,000. That's 1,792. I'm like, okay, good job. So then I might say, what's 792 plus 999? And then they just break out in a big old grin. Now, at this point, don't make working memory work against the kid. Feel free to write that 792 down,
Right.
like even if you just like type it in your phone, if that's all you've got handy, or scratch it on scratch paper or something. 792 plus 1,000. They're like, yeah, that's 1,792. Then plus 999. Well, that's going to be 1,791. Right. So I almost wished I'd just written that down. I didn't, but I like to hang on to the 792. That's not the game. The game isn't to make sure that they can
Hold it all in your
hang
head. Yeah.
hold it all in your head. The game is, what can you do with the relationship? So yeah,
Right.
super important that you think about any number plus 10, any number plus 100, any number plus 1,000. And then you can play with just what's a little bit more or less than that.
Yeah. And all of these ideas that we're sharing with you is all about creating flexibility and thinking about numbers more densely, being a little bit more creative with number. It's like you said, it's not about holding it in your head, but freeing them up to be able to describe values of numbers instead of just writing it down and plugging out, what they've always done.
Absolutely. And all those things you just described are what makes it playful, right?
Yeah.
That's the game-like aspect to it.
Yep.
Yeah. Okay.
Yeah.
All right. Go ahead.
Okay, so our last one that we want to share today is one of our very favorite routines called I Have, You Need, which is perfectly appropriate for very, very young students all the way up through adults. One of our favorites.
We love I Have You Need to get the combinations of these super important numbers, like combinations of 10. What do I mean by that? What numbers combine to equal 10? So if I have 8, Kim, you need
2.
to make 10, right? So if our total's 10, then you just literally call and response. So if our total is 100, I might say I have 85. So Kim, you need
15.
to make 100. And so it literally is just this, hey guys, today the total is 20. All right, if I have 13, what do you need to make 20? Go ahead, Kim.
7.
And then like playing with those relationships. So it's not about having the kid rote memorize those relationships. It's about having the kid figure them out, often in a game-like kind of atmosphere. So their brain does that, and they get better and better at kind of figuring it out and then owning those things over time. So then
And
you could
sharing with you how they thought about it.
Thank you. Very important. Yes. All this is conversation. You might even have them. You might say, okay, today, total 100, you go. And so then your child can say, ha ha ha, I'm going to give you a really hard one. All right. I have, and then whatever they say, 67. And then you're like, okay, that is a hard one. Let me think.
Yeah.
33. And then your student might go, how do you know that, Mom? How'd you know that? You could say, well, and then you can describe. Like, for example, you might say 67. Well, I need 3 to get to 70. And then I need 30 more to get to 100. Okay, so that's 33 I needed. Or you might think about, I needed to get 30 to add to the 60 to get up to 90. And then I need to fill in the rest of the 10. Since I started with 7, I need 3 more. And so I probably should have used one that had 33 in it. And then that would be 33. So combinations of 10, combinations of 100, combinations of 1,000, super important. So Cam, I'll just play one really fast with you.
Okay.
What if I said I have 844? 844, what do you need to make 1,000?
156.
How do you know? I know you own these so well. Can you even talk about your thinking?
Well, I'm not sure if you want me to share
I just want to hear how you're thinking.
Okay, so I had 844, and I knew that I needed 100 more to. It kind of went from left to right. So I needed 100 more to make the hundreds be 900.
Okay.
And then I had 40 in 844, so I needed 50 to make the tens column have 90.
Okay.
And then you said 844, so I knew I needed 6 in my new number so that I would have 10 in the ones place. So I wanted 990 and 10 to be what I was aiming for.
Because 900 plus 90 plus, oh, sorry, I didn't mean to interrupt.
No, because all that 990 and 10 makes the 1,000.
And that's what you were looking for.
Yep.
So yeah, it's a fine strategy. I'm glad you shared it with everybody. So great. That's the kind of thinking that we want you to share with your student and have them share with what they're thinking about as they get more practice in these important partners. These partners will come up in many important ways. Kim, if I could just give one example. Let's say that your student has to do something like, I don't know, 300 subtract 188.
Mm-hmm.
I'm going to say 288 just for simply.
Okay. Yeah.
All right. So 300 subtract 288.
Yeah.
In this moment, your student could say, well, gee, 288 is really close to 300. And if it's super close to 300, how close is it? Like,
mm-hmm.
I'm just finding the difference between those numbers. And then they could say, well, golly, 80, if we're playing I Have You Need, 88, what do I need to make 100? Well, I've done that a lot. I just need 12. Well, then from 288 to 300, I still need that 12. So the answer to that cranky subtraction problem, if I use the algorithm, is just 12. And I just thought about it using partners of 100 kind of inside those other hundreds.
Yeah.
So a place, these relations, it's only one, there's lots of places that they'll come in handy, but a really nice place they'll come in handy is when we do what they call subtraction across zeros, because you can just find that difference up there. One more iteration that we really like with I Have You Need is you can play total of 1. So with a few older students, with why did I say few? With all older students, you could say, when you get to some higher math, you could say, hey, today we're going to play I Have You Need total 1. What if I have 0.88 or 88 hundredths? What do you need to make 1?
Mm-hmm.
Now, some of you might smile and go, Pam, that's just like the same as 88 to 100. Yeah, but kids don't know that at first.
Right.
So 0.88 to make 1, well, I'm going to need what, 0.12 or 12 hundredths to get to 1. Or you can also play total of 1. So any decimal, just throw out a decimal and see what they do. You can also play total of 1 with fractions. So I could say I have 4/5. What do I need to make 1? If I have 4/5, what do you need to make 1? So some nice variations. Integers, you could say the total today is 0. If I have -15, what do you need to get to 0? That game doesn't play very long, but you can play it long enough to just kind of get 0 pairs kind of in there. Yeah. Y'all, one of the most frequent questions we get from parents is, do you have this stuff written down in one place?
Right.
And the answer is yes. We have a Tips for Parents free download. Woohoo! It lists the things that we've been talking about and more, with links to learn more about many of them. And you can get that free download at mathisforgettable.com/parent tips. mathisforgettable.com/parent tips is the link to get our free parent download that will list everything that we talked about today and more. And don't worry, it's free. So whether you're a parent who didn't like math, you're a parent who's just started talking to your kids about mathy things, or a parent who loves math and wants more tips to working with your student, download our free parentship. It is a great help for you. You can find that at mathisfigureoutable.com/parent tips. No space. Parent tips, 2 T's, parent tips. All right, y'all. Thank you for tuning in. And Kim, I'm pausing because I wasn't sure. You did the intro. Are you doing the outro?
Thank you for tuning in and teaching more and more real math. To find out more about the Math is Figureoutable movement, visit matheisfigureoutable.com. Let's keep spreading the word that math is figureoutable.
Thank you for listening and making math more figureoutable.
To learn even more, make sure you register for our free challenge at matheisfigureoutable.com/challenge. You are not going to want to miss the evenings of May 15th through 17th, starting at 7 p.m. Central.
Math teaching, go register now. That's matheisfigureoutable.com/challenge. Join us to make math more and more figureoutable. And if you can't join live, register and we'll send you access to the recordings. We'll see you there.